to ask for permission first. GDPR.
It's going to be coursework.
You can record. Make notes. Sign. Can't record.
The video log is going to Moodle.
Can't record. I'm joking.
Plug it.
Got one in there.
So, where are we at?
You tell us why you want to use the service now, and what's your plan?
Okay, on a personal level, we have a separate project. It's part of the cluster, but no. I'll turn the board around.
That's on the back,
I'll
yeah.
show the other side of the board.
So this is over the next year.
Yeah. So we're thinking what we're going to do for the third year project. Planning out, 10 weeks or something, which is now down to 8. There were a number of things that we want to do. One is build a cluster. Just Python programming, some machine learning, and build an application. The application is using blockchain technology as a voting. So we have a immutable ledger. So people can vote as an application on the phone or on a PC or laptop using the blockchain technology, programmed in Python and tested on the cluster. That's the main aim from certainly my third year project. I think Mickey's is more geared toward the security side, right? And hardening everything, hardening the code and hardening the infrastructure of it. And so, I'm sure this is not possible, but we really want to do a couple of kind of certifications as well as finish.
That's going to be quite difficult now with the time scale and
time scale that we have. And we were thinking primarily about where we're going to be over the coming months. For the first semester, I particularly chose the advanced databases for next year for the first, and then the project and the employability skills. And at that point, for the second semester, the app should be somewhere to proving the concept. There's a lot of maths and a lot of programming to learn. It's very modular. A lot of the code already exists in Python to do the blockchain, to program the app. Doing the interfaces is relevant. It's relatively easy, so we can achieve that. And the reason we want to build the cluster is kind of on the other side. So, it's really simple. It's a 4-node cluster, separate OSs, file systems, resource managers and schedulers, and then the elements that go over the top. It allows us to manage the cluster using the front end, and then we can instantiate anything that we want on top of that cluster, utilising its resources and making it more efficient. We can turn the cluster on and off, or the machine's on standby, so there's less power, less heat use. When we need to spin machines up and it requires processing or RAM resources, it will just boot up the machines. And Mesos allows us to do that. That means that when other students want to log on to that system in whatever capacity that turns out to be, whether that be externally or just internally, whatever you desire, we can do these number of things. And we wanted to, so they can put up web servers and databases, we wanted to build a pen test lab. So when it comes to the security, they can just experiment a little bit, by just logging onto the cluster as a client and accessing a pen test lab of some description. And then there's other things like when we're doing IoT for next year, the first and second year students, when they've got the data to analyse it, you could use the machine learning elements of Spark to analyse that data really quickly. There's no lag, you don't need to.
Like the cloud unit and stuff like that.
Because it's effectively you've got your own cloud.
Provision your own virtual machines and stuff like that. So you can actually go, not just cloud, but you could use it for obviously like web design and stuff like that, full stack development. It's a testing environment, development and testing environment.
As long as that element there, that main element, is solid and functional and hardened and secure and manageable, then all the rest is always, you're always capable of virtualizing everything, you know, whether it be the networking degree or CCNA or whatever, you can do it all. And anytime anybody wants to get hands-on with specific hardware and get to a server, there's these slightly older servers where they can kind of muck around with them, and if they damage anything, then, you know, if they start taking bits off them and plugging stuff where they shouldn't be plugged. There's older servers, there's older machines. I mean, it's not just the network society machines. I mean, there's those, the G9s, aren't there? And the G5s.
G8 and G9.
So that still gives, there's 10 servers there, plus these 4, plus the 9 on there. So there's 10 fairly, well, they're moderately reasonable servers where they could be used for a single. Yeah, so it's not depriving. By using these 4 machines together, it might seem like, well, you kind of resource hogging effectively. You're taking the brand new machines, they're fantastic, you're taking everything. That's not the idea. The idea is for us to be able to manage them, give out those resources, you know, and it means that it's, in terms of its efficiency, so you're not just burning power all day long. You know, you turn on and off at will, it's there, and it shuts down or whatever you need to do. So in terms of power requirements, heating, the amount of uptime, I mean, I think I calculate there's somewhere between 93 to 97% downtime on any of these machines that they're running. They're just sat idle doing absolutely nothing. And just, you know, somebody's taken that machine and kind of used it for a third-year project or whatever project they're doing, and most of the time they're performing the written work and that kind of stuff.
So on that
And
as well, though, when they're doing say security and stuff like that, you can have a safe environment to work in, so you know there's less chance of stuff getting broken and what else by using a virtual environment and stuff like that. But they can have access to these resources.
Safe
to do
environment.
many different things like application development, you know, full stack development.
Outside of hours, if people want to do the pen testing side, obviously I know that IT infrastructure services here are really nervous about that, using any of these computers. They absolutely panic. I've seen the faces when it gets mentioned. They just freak out about it. But if it's done on a cluster that's manageable and secure, it means they have an internal environment where it can be, you know, contained, sandboxed to make it closed off, secure, so they can do anything they want. They can build the systems and wreck them. It doesn't affect anything else. There's no risk to anybody. And like I said, it's about that efficiency. Rather than these single machines that are just, you know, they're sat there with somebody's label on for like 6 months of the third year, doing nothing, 90% of the time. They're just sat there doing nothing, so nobody else has access to them anyway. This way, these 4 new, you know, these 4 new nodes effectively, means that they have access to those virtual resources all the time. And then we wanted to do some slightly kind of more social things, which would be like the blogs and the vlogs and the RRC and stuff like that. And that means that they can start to log their work down, similar to we kind of should be doing on Moodle. There's an actual student place where they can go to and they can store some data, do the projects, and then, you know, away in a file. And that'll all be managed in terms of administrating the cluster and setting users, permissions, all the usual stuff that you do. So, you know. Well, I would think nobody else is going to understand that part of it, so that would need to be us. Yeah, that'd be kind of us, but really it's just through a front end, it's through Mesos itself, which does the cluster administration. That's just like ours, so you guys, if you need to, can have all the admin rights that you need, just like everybody else, it's just, so you've got access to everything, so you can see what's going on, so there's, you know, so it causes you a problem in any way. So that'd be kind of cool.
Full permissions.
Yeah. I think that would allow us to leverage the new machines, the cost of these new machines. And am I right in thinking each machine's cost about 10 grand each? Right, so £40,000 worth of machine will be sat there in excess of 90% of the time doing absolutely nothing. When you could advertise this outside the college and go, oh, we have a 100-student cluster where they can work, they can practice stuff, they have security labs, they can do this, they can do app development. And the real kicker would be if they had an external broadband line, which we've been asking for 12 months. That external broadband line would mean that students could work at home and access the resources and the parallel processing of the cluster. It means if they've got a really resource intensive something they're doing for a project, you know, maybe analysing data or some kind of data set, they can just leverage the power of that. And then adding clusters into that 4-node cluster is easy as well if you require even more. And you can distribute, just like any organisation does, including college, you can distribute all those resources, the distant memory, the time sharing of the processing, and the networking and bandwidth. You can allocate that to a given user. You know, if you get a user that's abusing the system, the logs will tell you that. You should log everything in the system, and it'll tell you immediately this person's, you know, kind of taking too many resources, and that's not fair on everybody else. Just, I'll see it as being manageable, but this is a long-term project for the next at least 12 months to the end of our 3rd year, where we get to do, for us on a personal level, we get to manage the hardware, understand, you know, cluster management, Linux management, command line, all those elements, harden the cluster, which is particularly important, particularly for Michael, doing that security and the hardening, the routers and the switches, and making sure it's absolutely rock solid, stable, like in a production environment. That's what we want to do. And then all the rest of the stuff, the programming on top, using machine learning, is that's where my interest is. And then programming the application to use machine learning and blockchain. And that will allow the resources to do that. And then eventually the idea is after we leave here that application will be moved to other cloud services.
Few questions. First of all, what you mentioned timescale 12 months.
I'm thinking to the end of the top.
Is that the project in a whole? Because the actual cluster itself, we'd hope to have done by September.
Yeah.
We start.
Yeah. The hardware and the cluster running and parallel processing properly should be 2 months, 8 weeks. So that takes us to September.
Fully up and running.
And that will give the opportunity then when everybody comes back in September, they can virtualise any environment they want to put that.
Which means children as well, running the courses, we give students access to these resources and stuff. But I also think as well, if you...
About September.
Yeah, it should be.
We're hoping to get it done over this summer. I know it'll be in every single day, so we're going to be working hard to make sure it's...
I mean, where we've got to with the other cluster is, we've got right up to the point where we're installing the yard. We've not got to the spark layer, the core layer. We're nearly there, we just didn't have a chance on the other cluster that we started out with. So we've got to kind of that point in that chain. These elements...
That point in 2 days, I think.
Yeah.
Now we've done it.
Once that layer and the management system's in, and all these permissions are kind of designed and the structures thought about, kind of flowchart and everything, all these elements for other students to work with are easy. They're 10-minute jobs. Really.
What's your current power or requirement for the resources that you have to cluster?
To cluster,
Yeah.
we'd have to gather a number of these machines that the students are working.
No, what you've got currently on the cluster side.
It's 4 nodes, 1 master, 3 slaves, 4 i7 processors. There's about, I think, 3 terabyte in each of those boxes as drives, but they're not provisioned as such as yet, but the hardware's there. And I think it's 24 gig in each box in terms of its RAM. And then 2 NIC cards, and that's it for that. Yeah. And we've used over that cluster, because obviously the cluster's in really 2 parts of the network. Same router, 2 switches, and those 5 nodes up there, which are they're just very unstable. You can't do anything with them.
And what are you looking to get from the new system? The resources?
Stability.
In terms of power.
In
In order to do this, we're talking roughly, students, numbers and that, and what we would probably need or what we've got in there. So what resources would you need?
It depends on...
I reckon you would need at least an octa-core in each machine to leverage, and at least a minimum of 64 to 128 gig of RAM in each machine to really make the stuff work and sing along. And that would allow you to just basically do anything that you want to do. There'd be not very many limits for students at that. You know, the amount of students that be online and having an instantiation of a virtual machine at any one time that's actually spin spinning at that time.
Well, that's good.
It's unlikely that you're going to have all the students at the same time using those resources. Just don't foresee it, because most of them are in most of the time anyway.
So,
There's not lots of it, but
No, that's true.
so if you were to get 384 gig RAM
Yeah,
and 40 cores,
more than enough.
and then you run a master node, the master node doesn't need to take the load.
No, it distributes.
Distribute.
It distributes. It uses the naming convention and
Yeah.
some data analysis to pass it.
Control.
Yeah,
Overall.
you need a name to back up the master.
You do.
So we have to do that.
but essentially, yeah, you're correct. The master.
So if we could provide you with that power
Yeah.
to start with, because what, see, we have loads of questions that we don't have answers to necessarily
To
to
us or-
ourselves, but it's not to you necessarily going forward. And we've got certain things in the plan. This plan is not a 12-month plan. You're talking a lot longer than that one. It's on two of you, considering you're going to be final year. You're going to be expected to focus on what Matthew and I do and other lectures that you're going in there, because we don't want you to lose on your classification over this. Yes, a lot of this will be embedded. It will help you, it will give you a brilliant experience and all that. But I think it would be unfair to expect you to take the whole and lot of burden on the development. So this is why I was saying time scale
The app development
and looking
is actually the thing I want to develop in terms of the coursework.
well, this is
That's
what
where-
I was trying to say, the time scale. So if you set the baseline and then focus on what you need, you focus on what you need, you create clear requirements in terms of your project, who is it for and how is it for, and you build on top of that, but you don't necessarily take the ownership of loads of these other things because they are overloading. They look great, don't get me wrong, they are absolutely,
You're saying the workload is.
you know,
is
but the
very intense.
workload will be in excess of 12 months.
Yeah, it's
And setting down those deadlines in front of somebody who's going to sign our contracts could get us fired.
Okay.
Because let's be reasonable. So that's why I was saying, you know, that we do have full service just been delivered. We had a quick check of well, it was a very quick check of what's there. And
Do they come with the rails for the rack?
yes, they do. There, the rails are there. So
drives and
they come with drives, they come with RAM, they come with processors. So 4 are there. So what we would like to propose is that we offer 2 of those to you to start the program on. You will have quite easy opportunity to add nodes at a later date.
It would.
You know,
I
you
would
wouldn't
suggest
need
this.
to do that.
If we started with 2 nodes, it's not sufficient to make a working Hadoop cluster. The file system requires a minimum of 3 nodes, a minimum. And then it doesn't work very efficiently. It actually requires 6 or nodes to do the job. So what we could do is do the 2 servers themselves, which would be, give us the processing power of the RAM.
Yeah, that's what it is, yeah.
But we could use elements of these other nodes that are working.
But we would have to utilize the current service.
Okay, we can do that.
What we would need from you as well is because we've met with Fraser, and Fraser wants us to give him exact number of PCs we have, the RAM we have, and hard drives. They're waiting for that information from us so they can start upgrading these systems for the next year. So we've been fairly busy with various other things as well, but we're going to have to take this ownership and do this somehow with help of you guys and other students, you know, definitely.
What would you do with the other 2 servers?
Well, the other 2 servers don't necessarily need to be in the background, but the 2 servers were meant to do something fairly similar, where they would do power. It would be located not here but downstairs, and they would be built and utilized by the platforms. So if we need, we can offload all
What's
four,
being utilised by?
utilised by platforms through the web from the classrooms here. Pretty much similar to what you're saying.
Yeah.
But there will be a
So
college.
So your,
It wouldn't be located
your
here.
general coursework will be